Let's look at interpreting solubility charts. First of all, solubility is how much a solute will dissolve into a given solvent at a given temperature. And so on this y-axis, just to standardize things, we're going to put different amounts of solutes in 100 grams of water. So that is our standard. And then we compare the temperature. So you see that some, as the temperature increases, you can dissolve more. And you see some that as the temperature increases, you can dissolve less. The gases, those are all, as you increase the temperature, then the solubility goes down. If you have a solid, as you increase the temperature, then your solubility goes up. Let's look at and try to find all the gases. So they're going to be the ones where their solubility decreases. So this ammonia gas, and then I have my hydrogen chloride gas, and then I have my sulfur dioxide gas. So those are all your gases. The solubility decreases as the temperature goes up. Now notice that my temperature just goes from 0 to 100, and the reason for that is because at 100 degrees I wouldn't have any more solvent to dissolve in because it would be boiling away. So it's just the liquid portion of water. 0 degrees, it would be a liquid. Less than that, it's going to be a solid, so you wouldn't be able to dissolve anything. So that's why our temperature just goes from 0 to 100 because we're using. Now each of these solubility lines represents the maximum amount of solute that can dissolve in that 100 grams of water. This line right here, this is what's known as the saturated solution line. Below the line represents an unsaturated solution. So under this line, that is your unsaturated solution. So notice there's a great area of unsaturated. Above the line, so that's right here, one of two things can happen. If you can keep it stable enough, you can have what's called supersaturated. But another thing that can happen is it can drop out of solution. So in other words, if I heat something up and then I cool it down, you might get solid appear once you cross this saturated solution line. So if I was right here, and it would be unsaturated, but if I cooled it down, sometimes right when you cross that line, solid is going to appear. And there is a video link with this video that you can see that it drops out of solution, the solid appears. We say a solute is very soluble if a lot of it can dissolve in water. So some that are very soluble would be potassium nitrate, again because it's a nitrate. Notice that you can dissolve quite a lot of it. This ammonium chloride, remember ammonium is very soluble. It always dissolves. Even this potassium chlorate. All of these actually right here, they are very, very, very soluble. Notice that in gases, as you heat it up, it gets less and less soluble. So I would say that if I was right here with SO2, I would say it's not very soluble. If I cooled it down, then I would say it's more soluble over here. At 10 degrees, which solute is the most soluble? So I'm going to look at 10, and the one that's most soluble is this one right here. So Ki is the most soluble at that temperature. And the least soluble, that one is going to be the KClO3. That's because that's that line right there. And so my KClO3 is the least soluble at that temperature. 40 grams of KNO3, so let's find KNO3. There it is right there. 40 grams of KNO3 is dissolved in 100 grams of water at 40 degrees Celsius. So I'm at 40 and 40. Make sure you pay attention to your X and Y axis, but I am right here on the graph. So let's answer this question. Is the solution saturated? If it's unsaturated, how much more material can be dissolved? And if the temperature drops to 20 degrees Celsius, what will you see in the solution? So let's go ahead and stop the tape and answer these, and then come back and I'll give you the answer. All right, the first question, is the solution saturated? And it would be no. This is unsaturated. It has to be saturated if it's on the line, and it's not on the line, it's under the line. Second, if it is unsaturated, how much more material can be dissolved? So I'm going to have to do a little bit of math. So I'm going to go from here to here. So let's see, it looks like I have about 38 grams. And to get it to be saturated, it needs to get up to 63 grams. So if we take that difference there, so if it's unsaturated, I can add 25 more grams, and that will take it up to the saturated line. So then I would be right here on that chart. Okay, let's do the third question here. If the temperature drops to 20 degrees Celsius, what will you see in the solution? So we're right here at the X, and it's going to drop to 20. And I can see that at 20 degrees, it's going to be over the line. So I'm going to see probably it drop out of solution. So more solid would appear. So it wouldn't dissolve as much because remember that's the saturated line. That's the maximum that can dissolve. So if you go over, some of that solid is going to appear and come out of the solution and drift to the bottom and just be at the bottom of your test tube. If you were able to keep everything steady and it was a more stable compound, you could possibly make a supersaturated solution. So let's answer these questions. This is just more practice. If you feel like you've gotten it, you can go ahead and move on. But this is KCl, so we're looking at this line right here. It says how much solute can be dissolved at 60 degrees. So find 60 degrees and then go and read it. So right at this point, and I'm going to say 45 grams. And then it says this solution would be saturated or unsaturated. And it looks to me like it's right on the line, so I'm going to say it's saturated. And it says if 50 grams of KCl is dissolved at 90 degrees Celsius, so let's find that point. So 90 degrees Celsius, and we have 50 grams. So we're just right under the line, like right there. It says, would this be saturated or unsaturated? It would be unsaturated because it's under the line. It says, if the above solution cooled to 50 degrees, so I'm going to take and just follow this line to 50, what would you see? So we would see solid appear. Or perhaps a supersaturated solution, so it would just stay the same. But it says, why does the temperature only go from 0 to 100 degrees? We already answered that, and that's because this is when water is a liquid. So unsaturated, this means that the solvent is able to dissolve more solute. Saturated means that the solvent can't dissolve any more solute. And a good example of this is if you're eating normal cornflakes and you've added a couple of spoonfuls of sugar to those cornflakes, not all that sugar is going to dissolve into the milk, and that's because the milk is cold. And remember with solids, the colder it is, the less that dissolves. So after you eat all your cornflakes, there usually is a layer of sugar sludge at the bottom of your cereal. That's an example of a saturated solution. So some of it did dissolve in the cold milk, but a lot of it didn't. It just floated to the bottom. So how you could get that sugar to dissolve is to increase the temperature. Increasing the temperature for a solid solute would increase the solubility. And then a supersaturated solution, this is a solution that contains more solute than a saturated solution. So if it didn't drop out of solution, it stayed dissolved, you would have an unstable situation, and we would call that supersaturated. In class, there was a demonstration of a supersaturated solution, and I will link a video so you can see a supersaturated solution, what it looks like. Basically, you take and you heat up your solid solute and your liquid solvent, and then you cool it down gently, and if it stays dissolved, you have a supersaturated solution. Now, how can you tell which of these solutions you have? You do what's called the crystal test. If I add a crystal to unsaturated, it will just dissolve more, so it will disappear. So I'll know it was unsaturated. There was room in the solvent for it. If I add crystals and they just float to the bottom and stay there, then that's a saturated solution. That means no more can dissolve. And if I add a crystal to the supersaturated solution, more crystals will appear and they will grow, and the whole thing will turn into just one big solid crystal if you have a supersaturated solution. Again, see the video that's with this so you can see what a supersaturated solution looks like. If you have a saturated solution, you have something that's at equilibrium. So you have dissolving occurring at the same time as recrystallization. If it does it at the same rate, then that is called equilibrium. The solid dissolves at the same rate as what is dissolved recrystallizes, and that is called equilibrium.